And in my part 2, I discussed very 4 important aspects of complex number. The first was the conjugate, then was the modulus, and the amplitude, and the modulus amplitude form of a complex number. It is very important that to know more about complex numbers. And this being such an interesting and important topic of mathematics, and one can say that as you proceed higher, to higher studies, this topic becomes very interesting and it becomes complex analysis. To analyze each problem of complex number, it becomes a parallel stream. Anything which is there for real numbers, we test for complex numbers. So a very important field of mathematics, this is complex number. And the very important point number 1 is, if x plus iy is equal to 0, if x is real, y is real, x plus iy is a complex number, and if it is equal to 0, if it is equal to 0, then you can write this as I0, that is x is 0. This implies x is 0 as well as y is also 0. So therefore, if I equate any complex number to 0, it means x and y are both equal to 0. You have to keep that in mind. That means 0 in complex number, yes, it exists, and it is in this particular form. Similarly, if I say 2 and I say x plus iy and I write 3 plus 2y, I have made a very important statement out here. How do you compare two complex numbers? How can you equate two complex numbers? Are you weighing two complex numbers? Are you measuring their length? No. Are you weighing them? No. How do you equate? So we do not equate, we write equivalent. And when I say equivalent, but in general sense, we would write equal to x is equal to 3 and y is equal to 2. You cannot compare, you cannot weigh. That is the case of complex number. But when this is equal to this portion is equal to real portion, this portion is equal to 2. So therefore, for a complex number, these are very important. And again, I discussed what is a z bar is x minus I bar conjugate of z is equal to x plus I bar. Z bar is the conjugate of the complex number z, which is x plus I bar, and z bar is x minus I bar. When I add these two, z plus z bar, these two get cancelled, left over is 2x, only 2x, that is real. It is, if I add two numbers, which is one is conjugate of the other, z plus z bar, it is simply a real number. And even if you multiply z into z bar, x plus iy into x minus iy, that is z into z bar is equal to x square plus y square, because I square is equal to minus 1. So therefore it is again a real number. It is real number. So therefore sum and even the product of two numbers which are conjugate to each other is a real number. These are properties which we are going to use while working out problems. The first thing I will do is how to express a complex number in complex amplitude form. I start express this is our complex number. You may express this as z. This complex number, root 3, yes sir, it is a real number. 1 into I, yes sir, it is a real number. So root 3 plus I is a real number, is a complex number. And when it is a complex number, so therefore, I have to express this particular complex number in modulus amplitude form. I have already discussed that, but with a proper example, you will proceed. I will consider one or two cases more. Now, z is equal to root 3 plus I. First and foremostly, I will determine its modulus. Mod z is root over root 3 square plus 1 square is equal to. I have obtained by modulus the value of this complex number mod z is equal to 2. Next, I will determine amplitude of this complex number. Amplitude of this complex number, amplitude z. This particular number is in the first quadrant. X, this is positive, 1 is positive, root 3 plus I is a complex number in first quadrant of Argand plane. If this is in the first quadrant, then amplitude z, recall from a part 2 of complex number, it was simply tan inverse y by x. That is tan inverse 1 by root 3. Y is 1. Y is 1 up here. And x is root 3. So tan inverse y by root 3 is the amplitude of z, which is equal to pi by 6. Try to use this gradient form of angle, that is in terms of pi. It is pi by 6. So my amplitude is pi by 6. My modulus is 2. This particular complex number may be written as 2 cos pi by 6 plus So therefore, it is the modulus amplitude form of the complex number or the polar form of the complex number root 3 plus. If your complex number given to be in the second quadrant, say suppose I consider this example, change a bit for your practice. Suppose z is equal to minus root 3 plus I. X is negative, Y is positive. So therefore, complex number is in the second quadrant. When it is in the second quadrant, therefore we know that mod of z, mod of z is 2, is same as this, but amplitude z would be pi minus tan inverse pi by 6. That is pi by 6. That is z is 2 cos 5 pi by 6 plus I sin 5 pi by 6. So first I would locate in which quadrant my complex number is. Here in this case, it is the second quadrant. I determine its value, the modulus, that is 2, and the amplitude pi minus, already discussed in part 2. If you observe, then z in modulus amplitude 4. So therefore, from this particular problem itself, we know how to find the amplitude also. This is a practice problem. Let me take another third example. Z is minus root 3 minus I. Both are negative, sir. X is negative, Y is negative. When X and Y are both negative, then the complex number is in the third quadrant. If it is in the third quadrant, mod Z remains 2. Mod Z remains 2. Distance of it from origin remains 2. Modulus is 2. But what is my amplitude Z? Amplitude Z would be pi plus tan inverse of 1 by root 3 is equal to, I am considering positive sign, pi plus pi by 6 is equal to 7 pi by 6. Just see the technique you have learned. If you locate the quadrant in which the complex number is lying, I have found out that in many textbooks that the determining amplitude becomes a bit confusing. Do not confuse yourself. Use the simple technique, pi plus. So 7 pi by, so this number in polar form or modulus amplitude form is multiplied as z is equal to 2 cos 7 pi by 6 plus I sin 7 pi by 6, 7 pi by 6, and so on. Now you can determine if the complex number is in the fourth quadrant. Root 3 minus r. You can do it by yourself. So now, at least it is clear that any complex number, if given, I can determine its modulus, amplitude, form, or the polar form of that particular complex number by the physical identity. Now, I will proceed with few more problems on complex numbers. question is, find the modulus of modulus of it's a very beautiful example, and that will clear many doubt of your also. In competitive exams also, you will be given another line number 30 minus 5. Such a large number. That means I have to multiply all of them and then divide by this. That will become huge. It is only there. The examiner is confusing you. Whether you know exactly how to find modulus of these type of complex numbers. It is a very important property that if note says if z is equal to z1, z2, z3 and y z5, then mod z is equal to mod z1, mod z2, mod z3 by mod z5. Very basic property, and it has lot of use, lot of application. That why complex number is in such a use form. And if a student starts multiplying this, it would not become large, it would become a huge problem. And ultimately you won't be able to solve. So to avoid, you need to know your basic. Your basic should be clear that if z is equal to z1, z2, z3 by z5, then mod z is equal to mod of 5. So therefore, mod z of this complex number is mod of root 3 plus r, mod of 3 plus 4r, mod of 30 minus 5i by mod of 5 minus 39. I am individually determining modulus of each complex number. I am not multiplying. If I multiply, it becomes a huge. So therefore, to avoid, I can write this as root. Root 3 square plus 1 square is 4. Root over 3 square plus 4 square is 25. 13 square plus this is equal to root over 13 square is 1 plus this is root 13 square plus 5 square by root over 5 square 13 square. These two get cancelled. 2 into 5 is equal to 10. 10 is the modulus of the complex number given as z is equal to this. So know your properties, proceed systematically. Do not go for rigorous method. Rigorous method will lead to disaster. I mean, it will become huge. So it will become very confusing. So stop there, think of this, and then proceed. Our next problem. 3. Find the modulus of root 12 plus I 1 minus I. This is a complex number, but it is not in x plus I y form. So, our first part is to simplify this and express this in x plus I y form. Until I know what is x and until I know what is y, I cannot determine its modulus or even the amplitude. So therefore, first and foremost, I will simplify this now. Root 12 plus I, 1 minus I, 1 plus I. And I multiply this denominator by its conjugate. That is root 12 plus I, 1 minus I, 1 minus I by 1 plus I into 1 minus I. I am multiplying numerator and denominator by conjugate of this number. 1 plus I, its conjugate is 1 minus I. So therefore, on multiplication it becomes root 12 plus I 1 plus I squared minus 2I divided by 1 plus 1. That is root 12 plus I 1 minus 1 minus 2I by 2. That is root 12. These two get cancelled. 2 and 2 gets cancelled. And my leftover is I into minus I by 2. 2 and 2 gets cancelled. Root 12 minus I squared root 12 plus 1 is the given complex number. Do not get confused. Plus it is I0. You may say, where is the I portion, sir? Everything is getting cancelled. I into I. Examiner has given you to confuse that whether you know that all real numbers are complex numbers or not. So I find that this particular is in fact totally a real number. The I portion is a 0. I repeat it once again. This type of problems are there in many of competitive exams, and you may be given in objectives also. 1, 2, 3, 4 observations are there. So therefore, how you would proceed? This may be part of another problem, that whether at all you express this, what is A, what is B, what is X, what is Y, how this is expressed as a complex number. So you have to say X is this and my Y is equal to 0. I repeat it once again. This is my complex number, not in X plus IY form. When it is not in X plus IY form, I express by its conjugate. And after doing that, I express root 12 plus I as this. This is equal to 1 minus I squared. I squared is 1. 1 plus I squared minus A minus B equals to 10. These two get cancelled. Minus 2 by 2. This is minus I squared. minus I square is 1. Since I is root minus 1, that implies I square is minus 1. So therefore, it now reduces to this form. And if the probability is mod of z or modulus of this complex number z, then that is equal to root over root 12 plus 1 whole square is root 12 plus 1. There is very interesting part to this root 12. Students generally get confused. The root is there, radical sign is there. Then the problem would be difficult to work out. Don't get confused. A difficult looking problem is actually very simple in form. I have seen by my experience. So don't get confused. Try to work it out step by step. You have to follow each step. Your mathematics should be such, your concept should be such that each step should be clear to you. You should be thorough with it. That it is okay. After moving, I get this particular motion. This is real. This is my real combination of these two are a complex number and its modulus is root 12 plus 1. So this is all as far as our part 3 is concerned. I will be working out with more problems for your competitive exams also, as far as this particular topic is concerned in part 4.